What's fascinating here is that this molecular data gave the health team a critical 4 to 6 week head start. They were looking at biological alarms ringing before the physical house caught fire.
A whole new era of communication in the global aquaculture industry is coming. Now you have the brightest minds in aquaculture right in your pocket. And what's best? You can listen to all of them while driving to a farm, traveling, or running errands. It's never been this good, and it's never been this simple. Welcome to the Aquaculture Podcast Show, the first AI-based podcast in aquaculture, where you'll find cutting-edge insights in everything that's working in aquaculture, nutrition, health, and production. Inspired by the 2023 article titled In-Depth Health Surveillance and Clinical Nutrition in Farmed Atlantic Salmon, a strategic attempt to detect and mitigate an HSMI outbreak, by Rennemo, Johan et al.
How do you stop a viral outbreak before anyone even looks sick? Welcome to the deep dive. I am your host and production specialist, and today we are looking into a massive challenge in commercial aquaculture.
And I am your resident veterinary pathologist. It is great to be here.
Yeah, we are heading into the cold, deep waters of northern Norway today to look at a really fascinating real-world study. It fundamentally challenges standard operating procedures for disease management, nutrition, and population health in large-scale farming.
Right, the proactive approach. We are looking closely at a 2023 publication by Johan Rennemo and colleagues. It is titled In-Depth Health Surveillance and Clinical Nutrition in Farmed Atlantic Salmon. A strategic attempt to detect and mitigate an outbreak.
And the core mission of this deep dive is to unpack exactly how that interdisciplinary team used predictive molecular diagnostics. They paired it with targeted clinical nutrition to basically preempt a severe disease event in an ocean pen.
Why Genetics turns podcast airtime into brand authority. We don't sell ads, we elevate voices. Curious how far your voice can go to become a reference in the industry and attract more leads? Scan the QR code and discover how we can turn your expertise into unmatched brand authority. Let's transform expertise into influence, starting now.
Okay, let us unpack this. To really appreciate the intervention, we have to understand the operational threat of the pathogen first.
Yeah.
In intensive salmon production, heart and skeletal muscle inflammation is one of the most persistent, economically damaging conditions out there. The etiological agent is Piscine orthorovirus type 1.
And that specific orthorovirus is ubiquitous. I mean, it is present across almost all major global production regions.
Absolutely. It is a massive biosecurity challenge. The pathology causes severe circulatory failure, epicarditis, myocarditis, extensive necrosis in the red skeletal muscle. You see significant fluid accumulation and hepatic congestion as the cardiovascular system just completely fails.
Which obviously translates to brutal economic losses for the producer.
Yeah.
While not every infected fish dies, the morbidity is effectively total. Infection rates in a challenged cage routinely hit 100%.
Yes, and the accumulated mortality during a severe clinical outbreak can climb to 20%. For a commercial site managing hundreds of thousands of fish per pen, losing 20% completely destroys your feed conversion ratio.
It wrecks the final harvest biomass. And the complication here, the thing that makes this a nightmare for production teams, is the lack of highly successful commercial vaccines.
Right. Establishing lasting immunity against this specific orthorovirus prior to seawater transfer is a massive biological hurdle. So production teams are forced into a defensive posture.
So if prophylactic immunization is off the table, why is reactive treatment so notoriously ineffective?
It comes down to the viral replication curve. Piscine orthorovirus targets the red blood cells for its initial replication phase before it even moves to the cardiac and skeletal muscle tissues.
So by the time you see the clinical signs...
By the time you see lethargy or a loss of appetite on the surface, the viral load has already peaked.
Wow.
The inflammatory cascade is well underway. Treating it reactively is biologically futile because the structural damage to the myocardium is already done.
Which brings us to clinical nutrition. We know that special health diets can help. They are formulated with targeted lipid profiles to modulate the inflammatory response.
But they require premium marine ingredients. They are expensive.
Right. You cannot afford to feed a premium health diet to a multi-million fish site all year round. It is cost prohibitive.
That economic barrier is the core question of the Rennemo study. You have a highly effective nutritional tool, but how do you know exactly when to deploy it? If you wait for symptoms, the heart damage is done.
But if you feed it too early, you erode your profit margins long before the pathogen even challenges the population.
Exactly. You need temporal precision. You need a highly sensitive early warning system.
And they tested this in a dynamic field environment, not a lab. May 2020, northern Norway, a commercial sea site operated by Ellingson Seafood.
The setup was perfect for a natural challenge model. They had two distinct groups. Group 1 was the focus, a single cage with about 200,000 Atlantic salmon smolts. Completely clean, negative for the orthorovirus.
But right next door was Group 2?
Right. Roughly 1 million salmon in 5 adjacent cages, just 45 meters away. And crucially, Group 2 was already confirmed positive for the pathogen before they even hit the seawater.
So relying on the water currents, the research team operated under the assumption that viral transmission across that 45-meter gap was inevitable. The healthy fish in Group 1 were basically sitting on a ticking time bomb.
Because transmission was inevitable, their diagnostic strategy had to be revolutionary. Standard regulations just dictate autopsying sick or dead fish.
Passive surveillance.
Exactly. But this team inverted that. Every 4 weeks for an entire year, they actively sampled 10 healthy, actively feeding fish from Group 1. They extracted blood plasma and harvested cardiac tissues.
It is like testing a random sample of people at a totally normal office party every month to catch a flu outbreak before anyone sneezes. You are looking for subclinical stress indicators while the system is operating at peak capacity.
And that proactive surveillance yielded a clear timeline. Through early summer, Group 1 was negative. The breach happened in August. The molecular diagnostics detected the orthorovirus in Group 1.
And genetic sequencing proved the virus jumped from the infected neighbors in Group 2. It highlights the massive challenge of horizontal transmission in open net pens.
August was the breach, but September was the aha moment. During the September sampling, the molecular data shifted dramatically. The concentration of viral ribonucleic acid in Group 1 reached its absolute peak.
And the host's innate cellular defense mechanisms initiated a massive response.
Precisely. The team documented a profound upregulation in specific interferon-induced genes, including viperin. The cellular machinery was aggressively signaling a severe viral challenge.
They also looked at blood chemistry. They tracked plasma levels of aspartate transaminase.
Right. That enzyme is usually sequestered inside hepatocytes and muscle cells. So elevated concentrations in the circulating plasma means cellular membranes are actively rupturing.
But here's the craziest part. You have maximized viral load, a screaming innate immune response, biochemical evidence of cellular lysis, but the fish looked completely fine.
That is the most vital takeaway. Feeding behavior was entirely normal. Daily mortality was negligible. Even on the necropsy table, the internal organs looked pristine. No macroscopic evidence of heart inflammation at all.
What's fascinating here is that this molecular data gave the health team a critical 4 to 6 week head start. They were looking at biological alarms ringing before the physical house caught fire.
Armed with that predictive data, they did not wait. In early October, they switched the entire population of 200,000 fish in Group 1 onto a specialized clinical nutrition formulation.
Let us break down that diet's secret sauce. Pivoting a commercial cage is a huge logistical undertaking.
The clinical feed features a reduced overall lipid content, elevated protein, and crucially, it maximizes marine-derived ingredients, a minimum of 14% highly unsaturated marine fatty acids.
And that alters the cellular membranes, right?
Yes. The biochemical mechanism is competitive inhibition. As the fish consume these marine-derived fatty acids, the molecules are incorporated into the cellular membranes. When the virus damages the tissue, the body mobilizes fatty acids to synthesize signaling molecules for the inflammatory cascade.
But because the diet loaded the membranes with specific marine fatty acids, the resulting signaling molecules are significantly less inflammatory than those derived from standard plant-based lipids.
It mechanically dampens the severity of the localized immune reaction. It prevents the inflammation from becoming so aggressive that it causes fatal collateral damage to the heart.
And the timing was incredible. Just a week into the new diet, the actual outbreak hit.
Mid-October, the early innate genes subsided, and there was a sharp increase in the expression of cytotoxic T-cell markers. The host's adaptive immune system had fully engaged to destroy the infected cells.
And that is when the physical cost became visible. Histopathological scans revealed active heart lesions. The clinical phase was officially underway.
The sequencing also confirmed this was a highly virulent genogroup known as Hi2. Historically, that genogroup causes massive structural damage to the heart and severe flock mortality.
So have 200,000 fish, a highly virulent strain, engaged adaptive immunity, and active heart lesions. Normally, you brace for catastrophic mortality.
But the mortality in Group 1 remained remarkably low. There was a minor transient increase, but the flock maintained its structural integrity.
And their appetite was completely unaffected. They kept consuming the clinical diet and growing despite the active viral challenge.
While we cannot mathematically isolate the exact percentage of mortality prevented without an identically challenged control cage, the physiological evidence is compelling. The clinical nutrition performed its exact function.
It did not stop the virus from entering or replicating. The proactive loading of the cellular membranes just blunted the worst physical manifestations of the viral wave.
Exactly. The heart lesions predominantly remained in the mild to moderate categories, preventing widespread tissue necrosis. It is a profound paradigm shift for large-scale aquaculture.
Relying on lagging indicators, waiting for dead fish, means managing the disease after the biological battle is lost. Implementing leading indicators changes the entire equation.
By tracking the viral genome and host immune genes in perfectly healthy individuals, production managers gain lead time. That allows for the strategic, highly targeted deployment of expensive functional feeds right when they will have the maximum impact.
Whether you manage a commercial salmon site, oversee poultry production, or track the health of any enclosed population, this proves there is massive power in finding leading indicators.
You do not have to wait for the obvious symptoms of failure.
Which leaves us with something really provocative to ponder. If precisely timed clinical nutrition and high doses of targeted marine fatty acids can so drastically alter the course of a severe viral heart infection in a population of salmon, what untapped potential does targeted population-level nutrition hold for managing emerging viral threats in other commercial agricultural species?
The cellular mechanisms are constantly providing data. The industry just has to build the diagnostic infrastructure to listen.
It changes everything about how we view proactive health. Thank you for joining us for this deep dive. We will catch you next time.
If you enjoyed this episode, make sure to follow the Aquaculture Podcast Show on your favorite platform. And don't forget to follow us on LinkedIn, Instagram, and Facebook to stay updated on the latest episodes and industry insights. Thanks for tuning in, and we'll catch you next time.